we have signs of very great changes occurring on the planet.
Everything happens so fast.
There's creeks dried up that have never dried up in my lifetime.
We've got a forest here that's already at the edge.
We're going into uncharted territory.
Our planet is at a crossroads. Global warming isn't out of control, but it soon could be. The warning signs are all around us. This is the challenge of climate change. What can we do about global warming? What will happen to the Earth if we don't? The temperature is rising. Each degree is critical.
Just 1 degree or so of
1 degree warmer than they should. Bump it up
So
2
2 to
degrees.
3 degrees.
Threshold is about 3 degrees of global warming.
3 to 4 degrees of warming.
You're starting to look at 4 degrees.
3 degrees, 4 degrees, 5 degrees.
6 degrees is almost unimaginable.
Imagine the 21st century if global warming accelerates. Where does the next superstorm hit? The next scorching heat wave? The next catastrophe? As the world warms degree by degree, the debate has ended. Scientists around the globe agree we now live in a world warmer by almost 1 full degree Celsius. Tracking the Earth's vital signs is an armada. Thousands of ships at sea, tens of thousands of stations on land, satellites monitoring from space. Scientists feed the data into the most advanced computer models to calculate what it means for our future. The predictions are alarming. In 4 decades, glaciers in the Himalayas, the source of water for millions, could be gone. Within 50 years, Greenland's melting ice sheet could be unstoppable. By the end of this century, the Amazon rainforest, home to half the world's biodiversity, could wither to an arid savanna. We're on the brink of 1 degree warmer, hotter than it's been in thousands of years. A temperature rise between 1 and 6 degrees Celsius is possible over the next century. Each degree means a radically different future. In some parts of the world, the first signs of global warming may be arriving with a vengeance. In Australia, bushfires are a natural part of the ecosystem, especially in drought years. But climate change may be pushing conditions from bad to worse. Australia's east coast is a tinderbox. In the winter of 2001, more than 900 fires encircled Sydney. They called it Black Christmas. Now, after a decade of drought, the danger is growing.
This year we had fires in Victoria that were very intense, and we fought them for months and months and months. So it is a bit scary, and the more the bush dries out, we're getting fires happen in areas we've never had them before.
Current data show the average global temperature has already risen 0.8 degrees Celsius. Victoria, Australia's second most populous state, is in the grip of one of the worst bushfire seasons in recorded history. For many, these fires are a warning, a wake-up call about what climate change can do.
Less than a degree of warming is what we've so far experienced, and that is enough to transform Australia, which was already the driest continent on Earth, into a landmass which has lost so much of its water that they're currently experiencing the worst drought for 1,000 years.
That drought has driven the fires out of the bush and into the front yards of thousands of Australians.
I'm a bit upset because Rob really wants to stay.
In some Sydney neighborhoods, it's an awful choice. Stay and fight the fire, or leave and hope your home will be there when you return.
Yes, Mum, look, I'm going to have to call you back. It's a bit of a fluster. Okay, see you, Mum.
A house is a house, you know, if we lost it, we lost it, but yeah, if you lose a loved one. It was our first house and we just bought it, so he was going to do everything he could to save it.
My wife left with the most important things, and it was up to me to make sure that it was going to all be there when she come back.
Okay, Rob.
No worries, honey. All right, I'll call you from your mum.
Okay, you take it easy.
No worries, you just get out of here. I'll see you later.
See ya.
Bushfires are already bad. Climate scientists predict in the next 3 decades they'll get worse. And it doesn't end there.
Global warming doesn't just mean the slow increase in average temperatures. It completely changes the way the Earth system operates, which is why we can see droughts in one place, floods in another, or even a succession of drought and flood in the same exact location.
National Geographic author Mark Linus spent years compiling data from climate models to understand how each degree of warming could threaten the planet.
It's very difficult for people to visualize the future impacts of global warming, and it's something that I really wanted to try and do to help people visualize the reality, because it isn't actually intuitive that the emissions from your car exhaust are going to be melting a glacier in the Himalayas in 50 years' time.
While experts estimate the average temperature could rise up to 6 degrees Celsius, or nearly 11 degrees Fahrenheit over the next 100 years, the future isn't set in stone. Even a small shift in the Earth's temperature, just 6 degrees, can have extreme consequences.
Well, 6 degrees shift from one day to the next is the sort of thing that we expect with normal weather fluctuations. If it's 6 degrees hotter tomorrow, I might just be wearing some shorts. 6 degrees in terms of a global average change. 6 degrees colder is the difference between now and the last ice age, 18,000 years ago, when the ice sheets themselves advanced to just the edge of Oxford, and in places the ice cap was more than a mile thick.
Just 6 degrees of cooling transformed the Earth into an ice age. Imagine it 6 degrees hotter. The very earliest changes would start high above the Earth. The atmosphere is our buffer zone between the planet's surface and outer space. A small percentage are the greenhouse gases, a cocktail of water vapor, carbon dioxide, methane, nitrous oxide, and ozone. They are like a dome over the planet, retaining just enough of the sun's reflected energy to maintain temperatures that support life. As the amounts of those gases increase, they trap more heat and can radically affect the climate all over the planet. For the last 250 years, greenhouse emissions have soared as we find more and more ways to use more and more energy. CO2 is the hidden price we pay. Carbon dioxide rises into the atmosphere from the energy that powers all our modern conveniences. It's literally in the air we breathe. There are now 383 carbon dioxide molecules out of every million. It seems minuscule, but as the amount of CO2 rises, so does the average temperature all over the planet. Doubling of CO2 is a guarantee for a global disaster. The dangerous level is about 450 parts per million, and we're already up to 383. Additional global warming of 1 or 2 degrees Celsius is a very big deal.
All we're doing is saying what we think our best estimate is what will happen if we carry on the route we're going. So all you can do is to lay out a number of possible pictures of the future and hope people will select the right one.
How will we respond? What will the planet look like if it's warmer by 1 degree, 2 degrees, 3 degrees or more? Are we willing to take that risk? If the world warms by 1 degree, the Arctic is ice-free for half the year, opening the legendary Northwest Passage for ships. Tens of thousands of homes around the Bay of Bengal are flooding. Hurricanes begin hitting the South Atlantic. Severe droughts in the western U.S. cause shortages in global grain and meat markets. This could be our world plus 1 degree.
At 1 degree additional warming to today, we're likely to see the emergence of new deserts in the western half of the United States, from Texas in the south right up to the Canadian border, is in danger of becoming new hyper-arid areas where really no crops can be grown at all.
In western Nebraska, ranchers depend on spring rains that aren't very dependable these days. Cattleman Bruce Wohler needs 15,000 liters of water every day for his herd to survive.
We've been hauling water here for about 20, 25 days, and sometimes twice a day. Looks like another dry tank.
After 7 years of drought, reservoirs are at their lowest in a century. Just keeping his herd alive is a daily struggle.
If the animals go without water, they die just like anybody else. When I was growing up, it was a lot greener, more water. There's creeks dried up that have never dried up in my lifetime. And I know even in my dad's lifetime, there's creeks that he said he never seen dry up, and they're dried up now.
Ranchers like the Wohlers live in sync with the weather and rely on its patterns. Knowledge that's been passed down through their families over 6 generations.
And that gave us a little bit of a benefit when we wanted to start up our own operation as young married people ourselves.
But past generations of experience that helped them thrive here may not be enough in a warming world.
I think it's just a trend that we're going through. I hope it is anyway. It'd be very difficult to keep ranching because a lot of this country's ungrazable, unusable for cattle if we don't have water. And if it turned into a desert type of climate, it wouldn't be cattle here.
Warming of just 1 degree could turn some of America's most fertile ranchland into desert again. 6,000 years ago, much of the American West was part of a vast desert dominating the continent. A minor shift in the Earth's orbit caused the summer sun to warm slightly, just enough to radically transform this entire region. Only a very thin layer of topsoil covers the desert sand that still lurks just centimeters below the surface. All it took was 1 or 2 degrees warmer, and the moisture disappeared. The 1930s gave us a glimpse of just how fragile the land can be.
So think of a repeat of the Dust Bowl situation and multiply it by about 20. This could devastate a huge part of the western United States.
But a shift of only about 1 degree could transform cattle country into a wasteland of searing heat and relentless drought. For now, the sands under this shallow soil are stable. But for how long? As we race toward a planet warmer by 1 degree, the global warming scorecard lists both losers and winners. While the western U.S. is dry and thirsty, England is enjoying an agricultural makeover. Fortunes will be made and lost if global weather patterns rearrange where different crops can be grown.
The winters, which used to be very hard in this country, are getting much, much milder, and so in some senses that's a good thing. That's of course not counterbalanced by the devastation which is affecting other parts of the world.
Right now, England is in the right place at the right time for one of the world's most fragile and most valuable crops.
You can't have it too hot for grapes, of course. You realise in the Champagne regions now it's becoming too hot.
When David Middleton first planted Champagne-style grapes, neighbors thought he'd gone mad. But as wine-producing regions in France are getting hotter, the climate for growing grapes is migrating across the English Channel. The idea of a fine English wine is no longer a joke. Now there are more than 400 vineyards in Britain. Middleton is planting another crop that's astonishing for England, again made possible by climate change: olive trees from Tuscany.
The olives will love it here. Our temperature in the summer will be that of the Mediterranean shortly, so therefore they will enjoy it and we will enjoy the olives later as well.
None of this would have been possible only a short time ago. The Earth's average temperature has always fluctuated, and a variable climate isn't unusual. It's the pace of climate change today that's unprecedented.
If you had asked us 10 or 20 years ago, what would be the impact of 1 or 2 degrees additional warming, we would say, well, probably we can live with that.
NASA climate scientist James Hansen was one of the first to sound the alarm about global warming. The threat has only escalated as he's struggled to be heard.
What we realize now is that we're getting so close to tipping points that we're going to have to stabilize atmospheric CO2.
Studying climates in the past has given Hansen a window onto the dangers posed by global warming.
In the last million years, it's never been more than 1 degree Celsius warmer than it is now. What we are doing now with the human-made greenhouse gases is an order of magnitude larger, and it's being introduced very rapidly.
The planet has experienced climate change before, but it usually plays out over thousands or millions of years. Now global warming is measured in decades, even years. It means scores of species won't be able to keep up. Warming at this speed could send us into uncharted territory, like nothing we've experienced in the history of life on Earth. Global warming started with our insatiable appetite for energy. Every switch we flip, every plug, every button we push to turn something on inevitably leads back to a place like this. Nearly 90% of the world's energy starts as a fossil fuel. Coal, oil, natural gas. But the chemistry of burning fossilized remains of prehistoric plants and animals is inescapable. Carbon dioxide. These 3 fuels combined are the single largest source of CO2 emissions pouring into the atmosphere. They've enhanced the quality of life for generations. It's hard to imagine getting along without them. Product by product, it may not seem like a lot to make one pair of sunglasses or light one sign. But the carbon impact of everything we do adds up.
I got to wondering, what's the carbon impact of something like a cheeseburger? Americans, all 300 million of us, eat an average of 3 cheeseburgers every week. And so that's like 150 cheeseburgers for each one of us every year. That's billions of cheeseburgers in the United States alone every year.
Among the scientists and other experts investigating climate change, Jaime Casio has staked out a unique territory.
I had to be able to calculate the numbers, calculate the actual solid, numerical, quantitative footprint of a cheeseburger.
The carbon footprint means all the energy that was consumed every step of the way for each of a cheeseburger's component parts.
When you look at the feedstock that goes to feed the cattle, growing the lettuce, growing the wheat that gets transformed into the bun, and milking the cattle, processing the milk into cheese, processing the cattle into beef, trucking all that stuff around, keeping it cold, it turns out each burger has a pretty significant carbon footprint of its own.
And carbon dioxide isn't the only greenhouse gas that's produced in the end.
But then it struck me, there's another critical part of the overall greenhouse gas footprint that I wasn't including. Methane. Methane from cattle. Well, the FDA calls it very politely enteric fermentation. It's what comes out of the cow. And methane, as it turns out, is the equivalent of at least 23 units of carbon dioxide.
Add it all up, all those cheeseburgers, and all that CO2, and you've got a very big number.
Pretty close to 200 million metric tons. 200 million metric tons of carbon dioxide equivalent just from cheeseburgers in the United States.
Casio has calculated that there are even more greenhouse gas emissions every year from cheeseburgers than from all the SUVs in the United States.
And this is just one kind of food. Think about all of the enormous variety of things that we purchase, we buy, we consume, and you realize that it's these everyday activities that are really the critical aspect of human activity leading to global warming.
Even at the lower end of the climate forecast, there could be fundamental changes in the way the planet functions. If the temperature rises beyond +1 degree, it could threaten nature's delicate balance. From the bottom of the oceans to the world's highest peaks. If the world warms by 2 degrees, some changes to the biosphere are no longer gradual. Greenland's glaciers are disappearing. So much ice has melted, polar bears struggle to survive. Insects migrate in strange new directions. As a temperate climate moves north in the U.S., pine beetles kill off the white bark forests, a grizzly bear's key source of food in the fall. New forests take root in Canada's melting tundra. The Pacific islands of Tuvalu are lost beneath the rising tides of global warming. This could be our world +2 degrees.
At 2 degrees of warming, the impacts in the marine ecosystem are going to be much more severe. We're likely to lose the vast majority of the world's tropical coral reefs.
It's a problem that's keeping Ove Herr Goldberg up late into the night.
To some, it might seem almost incredible that we could change something as vast as the ocean. I mean, the Pacific Ocean, I mean, if you just take that huge bowl of water, how could we change it?
a marine biologist at the University of Queensland in Australia, Ove is tracking changes in coral reefs.
They're acting a little bit like a canary in the coal mine. Miners used to take a little bird down with them, and when the bird got sick, they knew to withdraw because there was gas building up in the mine. Well, coral reefs are, a beautiful, biodiverse part of the Earth, and the very fact that that's disappearing should have all of us worried, just like the canary in the coal mine.
Located on the Great Barrier Reef, along the northeast coast of Australia, his lab is on the front lines in the war against climate change. Recently, the Great Barrier Reef suffered 2 massive bleaching events. When waters warmed past the coral's tolerance of 30 degrees Celsius, they began expelling the algae they need to survive. Large sections of the reef died.
When you jump off the side of a boat and you see a bleaching event, it really comes home to you, the scale of the changes that are going on. What would happen if we woke up one morning and 1 in every 5 trees in our favourite forest had just disappeared? Well, that's what's been happening in coral reefs.
More than 1 million different species live, feed, and breed around reefs. They need the reef. They literally can't live without it. The oceans are the planet's largest carbon sink, nature's primary mechanism for absorbing CO2 out of the atmosphere. But lately, there are indications these systems are breaking down. Under normal conditions, tiny sea creatures like forams and coccolithophores absorb carbon out of the water and use it to build their shells and skeletons. But there is a tipping point when too much CO2 in the oceans turns the water increasingly acidic. Acidification dissolves the creature's shells and skeletons and prevents them from absorbing more CO2 out of the water to build new ones. Some of these tiny animals at the bottom of the food chain measure only 1 millimeter. But the fate of all sea creatures, of all shapes and sizes, larger and larger, hangs in the balance. Alter the ocean's chemistry, and nature's primary mechanism for controlling the climate begins to break down.
You lose a coral reef, you lose perhaps 500,000 species. You lose those little coccolithophores, these little algae, and you start to lose things that are very important to life on this planet. We're losing some of the most vital elements of the way the world works, and that's got us all concerned.
Scientists half a world away share those concerns. They're investigating global warming at the climate's opposite extreme. It took nature 150,000 years to make the Great Greenland Ice Sheet that's now melting into the sea faster than at any time in history. As it disappears, rising oceans will flood coastal cities around the world. Greenland's Jakobshavn Glacier is the fastest moving ice field on the planet, more than 40 meters per day, melting into the sea twice as fast as a decade ago. In just 2 days, the amount of ice breaking off the glacier contains enough water for the New York metropolitan area for 1 year.
One of the greatest concerns about what will happen if the planet continues to get warmer is the stability of the ice sheets. And the danger is that the ice sheet could begin to collapse very rapidly.
Rising temperatures are transforming one of the Earth's harshest climates, disrupting the way people have lived in Greenland for hundreds of years. For as long as anyone can remember, sled dogs have been a symbol of wealth here and a necessity for survival, especially for hunting across the winter sea ice. When the winter ice started thinning, dogs became an expense most islanders couldn't afford. In this town of 4,500 people, there are 4,000 dogs, with very little to do these days. Many are starving. Some are being put down. Marit Holm is one of Greenland's 5 veterinarians. As she patrols the town of Ilulissat, she sees the impact of climate change in every sled dog without a sled to pull.
So that's what I do. I drive around and look after the dogs.
The dogs are hungry, so I have to be a little bit careful not to get bitten. And when the dogs are hungry, you know, they are a little bit more dangerous to people and kids walking around. It doesn't seem to be sick. He's very skinny. So I have to try to find out who's the owner and talk to him.
These animals were once in peak physical condition. They served a vital purpose in their owners' lives.
That's a thing of the past, and we don't see any young people who takes some dogs and live as a fisherman and a hunter.
Dogs have been in Finn Sistel's family as long as he can remember. He finally gave up his team of 19 just in the last few years.
In the winter, even though it was an impossible thing to do about 20 years ago, most of the fishermen go out with a boat today instead of dog sleds.
When Finn was growing up, this was their winter hunting ground. Solid ice for more than half the year.
Everything happens so fast. It's so visible, you don't have to be a scientist to determine what's happening.
With each passing season, Finn watches as traditions locked in the ice melt away.
There's something interesting in the side because you can see small bubbles. And these bubbles are older than all living creatures in the world. And you can listen to it. Because the bubbles are so compressed. And when they get out, it's like popping. You can talk to the ice.
That's what an intrepid team of scientists does once a year. Fly into Greenland's interior to listen to the ice. Swiss Camp is a scientific research installation built directly into the glacier to track climate change. Dr. Conrad Steffens leads the team that has to dig out every spring. Lately, he's found areas of the glacier that hadn't melted in thousands of years, covered in water every summer.
I just checked the weather station and guess what?
What?
It's not getting colder.
Oh, why not?
Yeah, we have record temperatures again in early January.
Some experts predict 2 degrees of warming could be enough to dismantle the glacier completely, but that would take thousands of years. Steffens suspects we could reach a tipping point much more rapidly, within the next 50 years, when melting would become unstoppable. To find out, he must venture even further out across the ice sheet. Steffens has erected 23 full-service weather stations that take a complete range of climate measurements every 15 seconds, updating global warming computer models all over the world.
The ice sheet is very old. It's over 150,000 years old. If we start to remove it, then we actually start a process that is unknown to civilization. We have never seen Greenland disappearing. Watch it, watch it, watch it.
In 1992, 5.6 kilometers of glacier was slipping into the sea and disappearing. 10 years later, that number more than doubled to 15.5 kilometers annually. Steffens wouldn't understand how warmer weather affects the speed of glaciers until he came upon one of the strangest and most dangerous features of this forbidding landscape. Rivers of melted ice are cascading straight down into the glacier, creating huge tunnels called moulins. The team lowers a fiber optic camera. Their hypothesis? That meltwater has cut all the way through to the bedrock a quarter of a mile below and is lubricating the underside of the glacier, propelling it faster and faster into the sea.
50 meters! My God!
60 meters. 70 meters.
For Steffens and his team, it is a chilling moment. This shaft, and many like it, go all the way through the glacier, revealing a whole new mechanism for speeding the ice sheet's disappearance. It's melting so rapidly now, oceans could rise as much as a meter over the next century. The consequences could be catastrophic.
The Greenland ice sheet actually contains enough frozen water to raise global sea levels by about 7 meters, which is enough to flood most of London, Bangkok, New York, Shanghai, you name it.
Many scientists focus on 2 degrees of warming as the tipping point that will fundamentally change how we live on this planet.
We are very close to the slippery slope right now. Some scientists already say it's probably too late to save the Arctic. I don't agree with that, but I do think we're very close to going to a situation where we would have no ice in the Arctic in the warm season.
This could be where global warming becomes a runaway train. Warming accelerates the loss of polar ice. The loss of ice accelerates warming. More water from melting ice absorbs more of the sun's heat, melting the ice sheet and heating the planet even faster. The warmer it gets, the faster it gets warmer. That's when global warming becomes a chain reaction we can't easily predict. Many solutions already available could, in combination, avoid the +2 degree tipping point. They add up quickly. From switching to fluorescent light bulbs to increasing the efficiency of the world's coal power plants by just 20%. Together, solutions like these can have an enormous impact before we start making irreversible changes to the Earth's primary climate control systems. If a rise of 2 degrees doesn't push the planet to the tipping point, many scientists predict 3 degrees will. If the world warms by 3 degrees, the Arctic is ice-free all summer. The Amazon rainforest is drying out. Snow caps on the Alps all but disappear. El Niño's extreme weather patterns become the status quo. The Mediterranean and parts of Europe wither in searing summer heat. This could be our world plus 3 degrees.
In a 3-degree warmer world, these kinds of summer heat waves will just be the norm. So an extremely hot summer by this point will actually bring the kinds of temperatures into Central Europe that you now experience in the Middle East and in Northern Africa.
The summer of 2003 may have opened a window onto life in a world that's 3 degrees warmer. All across Europe, an unrelenting heat wave developed into a natural disaster. Paris tends to empty in the summer. Many elderly stay behind. Nobody could have anticipated the danger they'd be in.
Never before would I have thought it possible that one could die of heat stroke at the beginning of the 3rd millennium in Paris. It was a terrible awakening.
Emergency room doctors were the first to realize something was terribly wrong.
Vers le 6, 7, 8 août.
Around the 6th, 7th, 8th of August, we started getting red flag warnings.
Les malades arrivaient et
The patients arrived and died from heat. This was not a pathology we used to be faced with.
Emergency room Dr. Patrick Pellew quickly realizes the heat wave is turning into a catastrophe.
Vous avez une telle vague de chaleur.
You had such a heat wave comparable to a flamethrower igniting an entire area.
Le nombre de personnes qui sont mortes dans la nuit du 10.
The number of people who died on the night of August 10 is between 2,500 and 3,000.
The city's distinctive metal roofs were designed for an earlier era to protect against winter chill. Now rising temperatures have turned them against the Parisians.
À Paris, les toits sont faits.
In Paris, the roofs are made of tin. Inside, the houses became a real oven.
The death toll would top 30,000 across Europe. In France alone, over 14,000 died in just a few weeks.
La canicule de 2003 est la
The heat
première.
wave of 2003 was probably the first huge catastrophe due to global warming that affected a rich country. A rich country that thought itself to be protected from everything.
Or, c'est faux.
Well, that was wrong.
If global warming increases to 3 degrees, it won't be the end of all life in Paris. But the character of this great city could be changed forever when extreme summer heat waves start coming every summer. During the heat wave of 2003, another little-noticed phenomenon among Europe's trees and plants was unfolding, a kind of vegetation backlash. Photosynthesis was breaking down. Under normal conditions, plants and trees are a first line of defense against greenhouse gases, absorbing CO2, then converting it into oxygen and releasing it back into the atmosphere. But in the extreme heat that summer, some plants retained oxygen, releasing CO2 into the atmosphere instead. Philippe Sieyès, a carbon cycle scientist, noticed unusually high levels of CO2 in satellite images of Paris.
We saw a large release of atmospheric carbon dioxide to the air from the vegetation. The trees were not able to take CO2 like they normally do, but they were releasing CO2, outgassing CO2 to the atmosphere.
What happens to the biosphere if one of the planet's most important mechanisms for converting CO2 into oxygen stops working on a regular basis? Possible answers are emerging here, at England's Hadley Centre, one of the world's foremost facilities for forecasting where our climate could be headed. Massive supercomputers factor in millions of weather variables to project the impact of global warming all over the planet. Trying to peer decades into the future keeps climate modelers at their desks over time.
Tea and coffee?
One of their toughest challenges is calculating the effect of +3-degree warming on the Amazon rainforest, where 20% of the world's oxygen is produced.
We wanted to know how climate change in the future would affect tropical rainforests, and in particular the Amazon, because it is such an iconic region, it's important both environmentally, ecologically and economically.
The climate model produces an ominous prediction. 3 degrees of warming could trigger a catastrophic feedback loop, accelerating global warming even more, possibly reducing one of the wettest places on Earth into a patchwork of arid savanna.
When you've seen these predictions of potentially enormous changes, and you think, well, yes, it's a very different world that our children are going to see, you can't help but be affected by it.
Occasionally it takes someone to come from outside and say, well, do you know what that means, don't you? You're talking about the death of the Amazon.
Summer 2005, the Amazon River. Extreme heat teems with the driest conditions anyone can remember. It's the perfect drought. Few can recall a time on the mightiest river in the world when its tributaries ran dry, not low, dirt dry.
In 2005, we saw a situation in the Amazon which was just incredible. It was completely off the scale. The Brazilian army actually had to fly by helicopter huge quantities of water up the dried up Amazon tributaries in order to stop people dying of thirst in villages which are normally on the edge of this enormous river.
First drought, then fire. In the aftermath of summer 2005, over 2,500 square kilometers of the rainforest burn. In the upper Xingu Park, the Kaseji tribe is on the front lines as the battle escalates. A fierce warrior tribe, they now face an invisible new enemy, one that could destroy their forest. The Kaseji men prepare for the struggle with a war dance for strength, passed down from their ancestors. In the past, they have fought to defend their land against commercial agriculture and deforestation. But this opponent is elusive. It comes armed with deadly drought and fire. Chief Kuisi already notices changes.
We used to be able to look at the stars, at the Milky Way, and know exactly when the rains would come for planting. But we cannot see any reliable pattern anymore. They do not come.
The Kaseji rely on the river, the rains, and the forest for their survival. Trees help generate 50% of the water for rainfall in the Amazon. As more forest is lost, the very source of the Amazon's rainfall diminishes.
For every tree that we lose, we're making one more incremental step towards a scenario of drought and fire in the region.
Ecologist Daniel Nepstad has been studying the Amazon for over 25 years and sees global warming and deforestation pushing the region toward a tipping point.
We think that maybe as early as 20 years from now, we're going to see what we call positive feedbacks kick in, these vicious cycles of drought leading to fire, leading to more drought. And that's much sooner, of course, than the climate models are giving us.
In the extreme conditions of a world warmer by 3 degrees, losing much of the Amazon could cause the re-release of hundreds of millions of tons of stored carbon, perhaps intensifying global warming another degree.
If we get to 30 years from now and the Amazon is brushland, I think I would look back and say we had a chance to save one of the world's great treasures.
A world warmer by 3 degrees could finally tip the balance on runaway global warming. Nothing in our past prepares us for these extreme conditions. A time when the rare 100-year storm becomes a common event. In a world warmer by 3 degrees, climate change could be manifest in the most violent weather humans have ever experienced.
People don't yet realize the changes that we're talking about could really lead to a different planet.
As the oceans get hotter and hotter, a new global climate pattern emerges, mirroring the violent weather anomaly we call El Niño. But in a 3-degree world, those extreme conditions could become the status quo. There's evidence for this in the past.
Back in the Pliocene, for example, when it was about 3 degrees warmer than it is now, the whole ocean circulation pattern in the Pacific was different, and there was essentially a permanent El Niño.
Normally, the trade winds drive warm ocean currents toward the western Pacific, leaving cold, nutrient-rich waters along the coast of South America. El Niño turns that system upside down. The first signs are wild fluctuations in air pressure. The trade winds weaken and completely change direction. Warm water spreads east across the Pacific. Torrential rains and flooding strike coastal South America. Indonesian rainforests and Australian farmland experience extreme drought conditions. And many climate models include another troubling forecast. Continued warming could turbocharge a new generation of superstorms.
In a world which is 3 degrees warmer, there's going to be a lot more energy in the world's oceans to drive hurricanes. And hurricanes derive their rocket fuel from the warming of the ocean.
Scientists are still investigating a connection between global warming and hurricane strength. Lately, they have seen more violent storms. Hurricanes are rated on a scale of 1 to 5. One study concludes in the last 30 years, there have been twice as many severe storms. The summer of 2005 would bring dramatic new evidence. In late August, a Hurricane Hunter aircraft is dispatched over the Gulf of Mexico. A colossal storm is building and tracking straight for the city of New Orleans. Anyone left there has only one word in mind: Katrina. By Sunday, August 28th, Katrina's winds reached 280 kilometers per hour. Thermal imagery along the storm track reveals Katrina's clout. Orange and red indicate the sea temperature has risen to 82 degrees Fahrenheit, a full degree higher than normal. Dropping pressure within the eye wall is the 4th lowest ever recorded for an Atlantic storm. It revs Katrina even more. Hurricane Katrina makes landfall in New Orleans, it unleashes a terrible fury. Within 6 hours, the storm is on its way out of the city. But the destruction of New Orleans only gets worse, transforming the natural disaster into a national tragedy. Jazz trumpeter Irvin Mayfield grew up in New Orleans. The storm surge and a breach at the London Avenue Canal sent 2.5 meters of water into Mayfield's neighborhood. His father stays to protect the family home. His body won't be found for weeks.
When someone has lost their high school, their junior high school, their elementary school, their pictures, their videotapes, their clothes, their friend's house, their friend's mother's house, their barber shop, the place they had their first kiss, you know, when you lose all that, and some people lost loved ones, when you have all of that come together, it's you can't imagine a type of tragedy, a citywide catastrophe, not even rivaled by September 11th.
2 years later, much of New Orleans still feels temporary. The wreckage is still overwhelming. The recovery still unfolding. It's impossible to directly link Katrina to global warming. The process that forms hurricanes is too complex. But many in New Orleans want to know if more Katrinas or worse are in their future.
After seeing what Hurricane Katrina has done and what it's continuing to do today, you would think people would at least want to start to get serious about figuring out this global warming deal and what that really means and what they can do.
In 2005, Katrina seemed like the storm of the century. But if the planet warms by 3 degrees, we could be in for a new generation of superstorm.
In a world which is warmer, then the hurricanes will essentially have a lot more energy to drive them. And so the most powerful hurricanes which we currently see in today's climate are Category 5. We could actually see hurricanes which are half or more category higher than that, Category 6 storms.
Imagine it's decades later. New Orleans is looking down the barrel of an unprecedented megastorm, the first Category 6 storm to threaten the rebuilt city. What if Katrina is only a hint at the magnitude of destruction climate change could cause? If the Earth reaches +3 degrees, over the next 40 or 50 years, the planet's basic life support systems could begin to break down. But beyond 3 degrees, the science of global warming becomes more and more speculative and more frightening. If the world warms by 4 degrees, oceans rise, overtaking heavily populated deltas, home to 1 billion people. Bangladesh washed away. Egypt inundated. Venice submerged. Glaciers disappear, shutting off the flow of fresh water to billions more. Northern Canada becomes one of the planet's most bountiful agricultural zones, while a beach in Scandinavia could be the next Saint-Tropez. The entire West Antarctic ice sheet could collapse, sending sea levels rising even further. This could be our world, +4 degrees.
At 4 degrees, we really do begin to see a planet which is completely unrecognizable from the one we know today. We will see the possible drying up of some of the most important rivers in the world, and this will endanger the survival of tens and even hundreds of millions of people.
If the planet is ever 4 degrees warmer, one of its great rivers will be self-destructing at both ends, from a high mountain glacier to the Indian Ocean. Locals call it Mother Ganges, the holiest river in India, perhaps in all the world. Millions of devout pilgrims gather each year in a mass ritual to celebrate the river's birthday. When it is said the goddess Ganga came to earth to save her people from drought. Himalayan rivers are the wellspring of life for over 1 billion people in China, Nepal, and India.
If Ganges is not there, then it will not be in India. It will be a desert in the world.
Climate scientists predict India could be one of the countries where the impact of global warming takes its greatest toll. Unless we begin to slow global warming in fewer than 4 decades, the Ganges could be a river fighting for its very life. The battle will be fought here, in the vast crystalline ice fields of the Himalayan glaciers, the planet's largest store of fresh water outside of the polar ice caps. Himalayan glaciers are receding, the fastest of any in the world. Few have ventured here to the headwaters of the Ganges as often as one man.
We used to have 8 to 15 feet of snow in a single night. Now you barely get 1.5 to 2 feet of snow during the entire season. The Ganges River will become a desert, and all you will see in her place is a dirty creek, not a thing of beauty.
Swami Sundaranand, an 80-year-old holy man known as the Swami who clicks, has been photographing the glaciers above the Ganges for 50 years.
1956 में सर्वप्रथम
The first photo I took of the glacier was in 1956.
ये मैंने गंगोत्री के
After 1962, I started to worry about the changes I was seeing in the glacier.
1965 में
I went to this glacier on foot in 1965, to the base of Meru Peak. When I went back after 15 years, the glacier had vanished. When I saw the glacier receding, I became very worried and started crying. If the holy Ganges is not in existence in the future, the entire world will seem like it has become an orphan.
The Swami's trove of icescapes documents 50 years of change to this magnificent glacier. Now, NASA satellite imagery confirms the rate of loss. Side by side, the high and low-tech images tell a similar story, one that spells danger for the future. Literally following in the Swami's footsteps is a new generation of climbers, lured by the pilgrimage to the glacial ice cave that gives the Ganges its life. When Nadish Sharma was a boy, his father was an early summiter of Everest. Since the late 70s, he's climbed the Ganges Glacier 30 times.
In 1978, This place, Bhojwasa, there used to be a dense forest of silver birch. And now, there is not a single tree.
The glacier holds millions of tons of ice. Nearly 20 cubic kilometers worth sustains the Ganges as it begins its descent to the Indian Ocean. This was all glacier once, before it started shrinking 30 meters a year. Just a century ago, this stone marked the edge of the ice field that has retreated high up the mountain.
I am sad because I have seen this glacier, my father has seen this glacier, but probably, maybe my children or their children may not be able to see this, which is the most holiest thing for we Hindus.
If current trends continue, the next 100 years could wreak havoc on agriculture, hydroelectric power, transportation, mining, and wildlife all along the Ganges. At first, the melt might unleash unprecedented floods. But then, seasonal water scarcity and famine could strike year-round once the glacier vanishes completely. At the current rate of loss, it's estimated there will be no more glaciers in the Himalayas by the year 2035, dramatically reducing the flow of fresh water to more than 1 billion people.
There are people depending upon this fresh water from the glaciers, but most of them will be gone if we have global warming of 3 or 4 degrees Celsius.
And that will lead to tens of millions of climate refugees having to go and find somewhere else to live. Pretty scary stuff.
At +4 degrees, different parts of the world will face very different kinds of problems, with only one thing in common. They will all be extreme. At 4 degrees of warming, sea level could be rising by 1 meter as the world's great coastal cities confront catastrophe. Among them, the largest and most densely populated metropolis in the United States. Surrounded by water, New York will no longer seem like an invulnerable fortress if it's up against storm surges powered by global warming.
This is Federal Hall here. Stock Exchange behind me. We're probably at about 15 feet above sea level, Alex.
Right.
The year 2050.
At +4 degrees, this could be beachfront property.
Flood to this level as well.
Same damage.
So now we're moving up to Broadway.
Armed with elevation maps and climate forecasts, Professor of Geophysics Malcolm Bowman and one of his graduate students plot the course future flooding could take through New York's financial district.
What will happen, there could be massive flooding in parts of New York City, parts of Manhattan here, especially the lower part. We could say that could be the flood line for a Category 3 hurricane hitting at high tide, a direct hit on New York City.
Even a Category 2 or 3 storm could submerge the financial capital of the world. New York is supremely vulnerable, both above and especially below the city streets, where much of the city's infrastructure is below sea level. The utilities that power New York are all buried underground: electric, water, and one of the most extensive subway systems in the world. Without them, the city would shut down.
The subway system is always fighting water. We pump almost 10 million gallons of water a day out of our subway system. We are, in many cases, the lowest point of New York City, lower than the sewer system.
If millions of liters of water are already flooding into New York's subway system every day, imagine the scope of the problem as ocean levels rise. For New York City, the problem is no longer theoretical. They have brought in one of the federal government's most technologically advanced agencies to assess the impact global warming may have. This NASA team uses computer models the same way generals calculate battle scenarios. These are war games. New York City versus a superstorm surge as sea levels continue to rise.
We don't necessarily notice the effects here in a major city like New York of, say, a 1 or 2 foot sea level rise every day, but we do notice it when a storm arrives.
People's houses are going to be flooded. They're going to have to be evacuating.
Computer simulations reveal a city in the wrong place at the wrong time. For a long time, disaster scenarios were based on the catastrophic 100-year event. In a world warmer by 4 degrees, they could come every 4 or 5 years.
We're not just talking about rising sea level, we're talking about huge dislocations. I think it's a catastrophic scenario for humankind.
If a megastorm hits on top of a major sea level rise, it will mean destruction on an epic scale. Parts of the city could be 7.6 meters underwater. One thing is clear, unless we limit the impact of global warming, major coastal cities will have to spend many billions of dollars to protect themselves. Various kinds of flood barriers are already on the drawing board, including colossal sea gates that can be opened and closed when a storm surge hits. New York would have to build 3 massive sea gates. One around the Verrazano Narrows Bridge blocking the entrance to the harbor, another behind Staten Island, and a third blocking the entrance to Long Island Sound. Anticipating a storm surge, massively powerful hydraulic engines rotate gates weighing thousands of tons, 9 meters out of the water. These sea barriers on the Thames cost Great Britain more than $1 billion, but they're protecting London from sea surges more and more frequently every year. At least major industrial nations have the option of mega engineering projects, with the technology to protect themselves and the resources to pay for it. It's likely to be a very different story in poorer countries that haven't contributed nearly as much of the greenhouse gases causing their disasters.
Can you dike this entire planet? No, you can't. And I think that's what we really need to be worried about.
Dr. Rajendra Pauchari chairs the Nobel Prize-winning panel on climate control.
I'm worried all the time at the direction that the world has taken in this day and age, which is not sustainable.
At the upper limits, +5 and 6 degrees, the effects of climate change are much more difficult to predict. Beyond that, genuine disaster scenarios could become a reality. If the world warms 5 degrees, 2 massive uninhabitable zones spread into once temperate regions of the northern and southern hemispheres. Snowpack and aquifers that feed the world's great cities, Los Angeles, Cairo, Lima, Bombay, are drying out. Climate refugees number in the hundreds of millions. this could be our world plus 5 degrees.
I think in a world which is much warmer than now, 5 degrees, it's going to be inconceivable that human civilization can withstand that kind of a climatic shock.
Now we enter the twilight zone of climate change, a nightmare vision of life on Earth. Perhaps most frightening of all is how much we can't know. Traditional social systems would break down.
I think it's the poor everywhere that are going to suffer, because if you take the example of, say, Hurricane Katrina, which I'm not saying was necessarily caused by human-induced climate change, who were the worst sufferers in the city of New Orleans? The poorest of the poor. They were just left behind.
The best way to survive the catastrophe of a hotter planet is to prevent it from happening in the first place. Failing that, we may be confronting far more difficult choices.
The survivor of the future is mobile. Mobility is the key. You've got to be able to get from place to place. If you think that you can hunker down in one area, you're wrong.
Eitan Edwards travels around the country offering personal preparedness training designed to survive disasters like the chaos of a climate meltdown.
Katrina was our lesson, but Katrina was a lesson that's going to be repeated again.
Edwards is convinced survival is just a matter of planning ahead and a little ingenuity. His gadgets are low-tech but effective.
In New York City, because there's so many windows and doors that you've got to move through and get out, a critical tool would be a mini pry bar. I carry mine with me all the time.
It's not likely we'll reach plus 5 degrees in our lifetime, but Edwards has prepared everything he and his family might need, just in case.
And what we have here is what I call an urban nomad bag. And that means you're going to basically have a bag that is your home. So you need everything that you have in your home in the bag.
If the worst should happen, Edwards is ready to become a New Age hunter-gatherer, carrying what he needs on his back, living off the resources he finds along the way.
Well-stocked first aid kit. These are toiletries. You can put about 5 gallons of water in this. Regular old ramen noodles. Old military mess kit. This is a 6-person tent. People don't think that you can actually have, carry your home with you. There is no more permanence. In fact, they should probably remove the word permanence from the dictionary at this point. It's the death of permanence. It's all about mobility.
If we allow global warming to take off that far, I really do see a situation where we have conflict across vast areas of the globe as the people who remain and the people who survive fight it out with each other for what remains of the world's resources.
And it can get even worse. If the world warms by 6 degrees, from a distance, the oceans may appear bright blue, but they are marine wastelands. Deserts march across continents like conquering armies. Natural disasters become common events. Some of the world's great cities are flooded and abandoned. This could be our world plus 6 degrees.
Warmings of 6 degrees over longer time periods have been associated with some of the most devastating mass extinctions which have ever taken place. So it's certainly fair to assume that if temperatures soar by 6 degrees within less than a century, that we're going to face nothing less than a global wipeout.
6 degrees of warming has been called the doomsday scenario. Our lives would never be the same again. But it's not all doom and gloom yet. Most experts believe we can awaken from the nightmare. Right now, the average temperature has only risen 0.8 degrees Celsius. but we don't have much time. 2 degrees hotter puts us on the brink of runaway global warming, when it could dramatically disrupt how we live our lives.
The scientific reality seems to be that we have to, if at all possible, peak global emissions within the next 10 years, or by 2015. And this, of course, is an extremely tight timetable. We're talking about turning around the energy supply for most of humanity within the space of a decade.
For anyone looking for solutions, there's no place like home. This is the Cohen residence, a pleasant 3-bedroom in Snowmass, Colorado. But lurking beneath the surface, an energy-eating monster. More than half the electricity in the United States goes into buildings in one form or another. Many homes waste more energy than they use. A team of eco-detectives is investigating the Cohen house for crimes against the climate.
This innocent-looking thing here, when it is on, eats a whole lot of money. When I feel this much cold on the outside of the freezer, I know that the insulation is really not as thick as we would like. Oh, what have we here? Climate change is a problem we don't need to have, and it's cheaper not to.
For Amory Lovins, solutions start with efficiency.
Bounce up on the ceiling.
Reducing the use of energy that produces CO2 emissions.
I think once people understand that climate protection puts money back in your pocket because you don't have to buy all that fuel, political resistance is going to melt faster than glaciers. Do you see that little red light down in the corner?
Lovins is a sort of new age meter reader, hell-bent on killing wasted watts.
If you have all kinds of appliances, you know, your TV, your VCR, your DVD, etc., that have that little light on, yes, they're using electricity. It's called vampire loads.
109 watts, almost $60 a year just sitting there turned off.
If every household in the U.S. killed off their wasted vampire loads, we could eliminate at least 18 coal-fired power plants. Lovins doesn't just talk the talk. He lives in a house he designed without a furnace in Aspen, Colorado, where temperatures in winter routinely drop below -17 Celsius.
We're at 7,100 feet here. It can go to -47 F, get frost any day of the year, and we can get 39 days of continuous midwinter cloud.
Lovin's house is a mix of high technology and homespun common sense. Solar units on the roof produce more electricity than the house uses. The entire house runs on just 120 watts, slightly more than a single light bulb.
Energy efficiency is the biggest, fastest, cheapest way to solve the climate problem, to save money, and to make a safer, richer, fairer, cooler world.
Next to our homes, the second largest source of emissions we're responsible for is parked right outside. Cars produce nearly 20% of global greenhouse gases. Nowhere is the problem of emissions from transportation more urgent than in developing countries, especially China. Rising affluence has paved the way to many of the perks of middle-class life, like owning a car. The numbers are staggering. So are the emissions. 14,000 new cars hit the road every day.
I don't think we can turn around to the Chinese and say, I'm sorry, we need to save the future of the planet. The rich countries have to take the lead, and we have to cut our emissions in a much more dramatic sense in order to allow some room for growth in the poorer countries.
To keep warming below the critical 2-degree threshold, we need to cut 7 billion tons of greenhouse gas emissions every year. Doubling the average fuel efficiency of all cars from 25 kilometers per gallon to 50 would save 1 billion tons. But we would still need to cut billions more from our carbon footprint to stay on the safe side of +2 degrees.
We have an arsenal of solutions already. It's going to be solar, and it's going to be wind, and it's going to be tidal power, and it's going to be thermal power. All of these different things working together actually give us a pretty good ability to get away from the fossil fuel economy.
They look like some giant robot army marching across the landscape. Wind power and windmills date back thousands of years. With today's technology, one wind turbine can power about 300 homes. They're a 100% clean and renewable resource. But wind power is no panacea.
The fuel is free, but the maintenance is not free, and we're seeing a lot of problems with the units.
And of course, nature controls the on-off switch. On a global level, it would take more than 2 million wind turbines to replace coal power plants worldwide. The ultimate answer may be just over the horizon. But the problem continues to grow. With each passing year, we consume more energy. The future will test the best minds in science. These are still the early days of climate change. The longer we wait to do something about global warming, the harder it will be to solve, requiring more science, more money, and more global cooperation. An international team of physicists in England has already started, attempting the mother of all technological solutions: nuclear fusion. They're building a fusion reactor modeled on the single best power plant in the solar system, the sun. Harnessing that same power could mean a virtually limitless and self-sustaining source of energy without producing any greenhouse gases.
This energy lights up the universe, powers most of the stars in the universe. So what we're trying to do here is to replicate the same process on Earth and use this amount of energy to produce electricity.
It won't be easy. With the volatile gases involved, engineers can't work directly on the reactor's core. They depend on a new generation of robot, some of the smartest and most skillful ever invented to work in such extreme conditions. The core of the reactor will be nearly 10 times hotter than the sun. A powerful magnetic field contains the superhot plasma and prevents it from melting through the reactor's walls. Even if it works, and there's no guarantee, the reactor won't produce commercial electricity for at least another 30 years. As ambitious as it may be, fusion may appear relatively down to earth. Imagine outer space filled with a cosmic fleet of mirrors. One current research project estimates that 1 million mirrors, each about 3 feet across, could block out enough of the sun's heat to lower the Earth's temperature.
It's no good sitting around hoping that someone's going to invent some fantastical new source of free energy, or a solar mirror which is going to reflect enough of the sun's rays to keep us tolerably cool. The reality is we have to deal with what we've got, and we have to do it within 10 years.
With or without us, the biosphere has always done an excellent job of cleaning up after itself. the planet has both the resources and the experience to deal with global warming. It's done it before. Global heating also spiked during the Cretaceous era, between 144 and 65 million years ago. It is the age of dinosaurs. The climate is changing radically, but slowly, over millions of years, giving many species a fighting chance to adapt over time. A period of extreme volcanic activity floods the atmosphere with 6 times the CO2, sending the average global temperature skyrocketing. It takes millions of years, but nature scrubs all that extra CO2 out of the atmosphere. It's absorbed through natural carbon sinks in the oceans and plants, and buried deep in the earth. Then, over millions of years more, it's fossilized. Billions of tons of carbon infused with the power of the sun were buried throughout the Earth's history. Those fossils sunk deep underground, producing enormous reserves of coal and crude oil. That's where the CO2 nightmare ended for the Cretaceous period, and ours began. It's the final irony of global warming. The very same carbon that was scrubbed out of the atmosphere so long ago is now being pumped back into the air every time we burn those fossil fuels. And it's warming the planet all over again.
Lo and behold, humans come along, we dig the stuff up, we find it's an incredibly valuable energy resource, and without thinking about it, we burn it and return this carbon back to the atmosphere in the space of less than a century.
In effect, we're reproducing the extreme conditions of the Cretaceous era, only this time at breakneck speeds. So quickly that most species won't have a chance to adapt and survive. The world's appetite for energy remains voracious. Our carbon footprint is staggering. As global warming escalates, it also accelerates. At some point, climate change could take on a life of its own, and global warming would become a runaway train. The only question is, now that we know about it, what are we going to do? Even the worst-case scenarios of 6 degrees won't mean the end of all life on Earth. But the planet after extreme global warming would be radically different from the life we know today. How bad could it get? At that point, the best minds on Earth agree on 2 things. They just don't know, and they hope we'll never find out.